told your friend you're not okay, and tell me what's wrong and why you never said you felt that way. And guess you're trying to stay strong and fake a smile until I look away. But I've known you too long, it hurts to watch your blue eyes fade to gray as you fade away.
Okay, back working on the Volvo again. I'm going to be working on adapting this 2JZ intake to something I'm going to make. So I do have this piece of 6160 aluminum, 1/2 inch by 3 inch. I think it's 36 inches long. And then I got a 2-inch piece of aluminum tubing. And I believe this is like 065 wall. And the ID measures the same as the flange that came with the intake. So this is kind of a budget intake idea. I want to say I paid like 40 bucks for this, 30 or 40 for this, and then the 2JZ manifold was like 150, 155 on eBay. So that manifold comes with this flange and a bunch of fittings and mounting hardware, bolts, all kinds of stuff. It comes with a whole bunch of stuff, and what I'm going to do is I'm going to try to make a flange with some runners that's going to bolt onto this thing. So I kind of pre-mocked this up with some tape. This is going to be a very, very manual method of doing this. So I know that there's flange designs and stuff on the 4200 wiki page. If you don't know that that page exists, go check it out. There's a 4200 wiki similar to the Sloppy Mechanics LS wiki, and it has a lot of good information on it. There's some flange designs that are on there. So one option is just like getting that flange design and then sending it to Send Cut Send or something like that, or having somebody do it. But what I'm going to do is a little more manual method and grunt a little bit, and I'm going to take this piece of tape as a template, lay it over the top of this thing, trace it all out, and do some cutting. And it's probably not going to be a whole lot of fun, but we'll make it work. So one challenge with this thing is going to be the 4200 runners are really wide, and then this 2JZ stuff is really narrow. So a lot of the runners have to come inward a lot and point towards the center, but should be able to make it work. Okay, so I got a little bit of a mess started here, and I have the template on, and this is the method. I got a 1-inch hole saw, hole dozer, this bad boy here. These things are awesome, and this is essentially what I'm doing. So I have the outline on the intake port. This is when it was taped to the head, and then I cut it out with the blade. So the dimensions should be pretty close, right? The tape's a little crooked. It's not perfect. We understand that, right? Next plan was I made a punch mark in the center. So I measured from the top to the center. So those are all exactly the same distance from the top, which is the factory edge on the aluminum. And that edge lines up with this top edge here. So the measurement for the punch mark is in the center hole vertical, the center of the hole vertically. And then what I did for the outside portions was I just took the hole saw with no bit inside of it, and then laid it on the inside of the green tape, a little bit set in, and then ran a drill bit through the middle of it and made a punch mark. That's more so to get the distance from the outer edge. So I feel like that should get me pretty close, and then I won't have a whole lot of material left to hog out, which I'll end up using like a burr bit or something to clean those up. But if I look at how this lines up, and then I compare it to the inside of the port, it's actually pretty close already. Because this port is 1 inch from top to bottom. This side is like 1 1/8, so that's why I got the 1-inch saw. And I don't think it needs to be perfect as far as like port matching and stuff goes. I believe this diameter, inner diameter of this hole is smaller than what that is anyways. So I'm just going to get it close. I'm not going to be too fussy about it. I also did do the math on these intake runners compared to the throttle body inlet size. And 4 of these inlet runners is the same surface area as the throttle body opening. Including the last two ports, these 4 holes have about 50% more area than the throttle body opening. Okay, here it is, kind of mocked up on the factory intake just to line up the bolts. So what I did was I have the tape on the other side and I just used the bolt holes and I pressed it into the tape, and wherever there was a witness mark on the tape I drilled a hole there. So that worked out okay to line everything up, and honestly the majority of these holes are lined up pretty flush with where the intake is. So I'll try to get a decent shot of this so you can see on the back side where the intake is, and it's pretty flush with the holes. So I think what I'm going to do is just kind of flatten out all these little points now. So I got a little burr bit, and I think what I'm going to do is just trim these down, kind of oval them out, and I might just leave it like that. Alright, after a little bit of time making some dust here, we got something that resembles an intake flange. So it actually fit up pretty nice. All the bolt holes, at least the ones I've tested, line up pretty well. There is a little bit of a step going into the runner on the inside, so I could probably make some adjustments to that, but I'm not too worried about it. Overall, like the side-to-side fitment and top-to-bottom, actually, like some of them are actually flush with where they were drilled, so that's pretty good. So I think what I'm going to work on next before I get too detailed with this thing is trying to mock up where this needs to be and try to get a gauge on what I have to do with all of the pipes. Okay, here's what this looks like with this positioning here for the intake. It's a little lower than I think I would like, but I think it'll be easier to build this way. The main concern is, so at this height I think it looks a little bit better, but it pushes it in quite a bit farther, and then I have like a weird angle. So at that position it's about 3 inches, maybe a little less than 3 inches of spacing here. But then instead of just going in, I have to go in and up with all of them, and it's also covering a shorter distance, so it'd be a weird angle. So this position here, it's down a little bit farther, but I can go out about another inch and I don't hit the master. And then I got about 3 3/4 inches of clearance here, and then I can just go straight in with the runners. So runner in here, runner into here. So I think what I'll do is I'll use the center point on the flange, because there's also a center point right here in the middle. So I'm going to bolt those up with a spacer like 3.5 inches apart, and then that should kind of be my template. Alright, check this out. You guys are going to like this one. So I do have one hole that lines up there. This is the hole I was talking about, kind of using as a reference point. And there is another hole in the flange, but there's not a hole in the 4200 side flange. So what I'm going to do is use this drill bit and mark a hole. And I'll probably end up drilling this one out a little bit bigger. This one fits snug into this flange. And this one's 352 thousandths, 0.352. So what I'm going to do is I'm going to make some dowel pins that press in there with a shoulder on it that's 3.5 inches apart. So, and what I'm going to use for that is my aluminum hood prop that I've been using. So I bought this for something else, and I've just been using it as a hood prop. It's a 5/8 inch aluminum rod. So I have some length here. So what I'll do is cut it at 4 3/16 long, maybe a little bit longer, and then I'll shave it down as I need to. So I'll have a 1/2 inch that presses into here. I'll have 3/16 that presses into here, and then I'll put a little shoulder on each of the rods so it'll hold it like here for my spacing, and then I'll be able to cut the pieces in between off of the car. Okay, so now what we have here is something that looks like this. I did bolt the flange on just with 2 bolts. The nut and bolt package that comes with this thing is very confusing. A lot of different sizes, a lot of like not enough pieces, really weird combination. But anyways, so this is what I have. I have a 1/2 inch here and then about 3/16 here. So then this will go in there. It's a little loose. They're not perfect. But now what I can do is I can go down here. I can slide the 1/2 inch section into the flange. And I can kind of hold the intake on there. So that's about my spacing that I need, 3.5 inches. But general idea is that we got the 3.5 inches front to back, and I'm probably going to end up having to tuck the throttle body under the battery bracket or relocate the battery. That's kind of what we got for clearance around the master. Now I'll go ahead and mock this thing up on the bench or on the welding table, and I can start trying to fit some pipes. Nice shape. Alright, so I spun that flare down a little bit on the lathe, and now they match. Well, last video I worked on making some of these sweet velocity stacks, so I ended up making a little press die that I can use on the hydraulic press here and put a piece of metal in and press it down and the stack comes out of it. The issue with this one though is the holes are really close together compared to the 4200 holes. So what I'm going to end up doing is cutting this whole bottom section out, and I'm going to follow this casting line all the way around here, and then I welded these plates in so I can hole saw in on each end, and then I'll do a 4-inch hole saw, cut the ends out, and then I'll have the open section. And then this 4-inch piece was just extra that I had laying around, so it kind of makes sense because this 4-inch is exactly the same width of these casting marks here, so it makes sense. I don't even remember what I originally had this 4-inch piece for. I've had it for a really long time. It's there, so I'm going to use it. And this is kind of what I started to mock up initially. And I have the 4200 flange that I just made out of a piece of flat stock. The center runners actually worked pretty good, but once I got out to the outer runners, you can see how much of a difference it is. It's off by 1 full hole, so to take that 2-inch pipe and then go all the way out, it didn't really work that well. So with cutting that whole bottom section out, it'll bring this center hole out more in line with what this one is, and then it'll probably have an angle similar to this, so it should work a lot better. Alright, a little unconventional method here, but I don't really have anywhere to clamp it, and it's a weird angle, so this is what I'm doing. 4-inch hodozer to the rescue. Okay, so I did get the whole bottom section cut out and then taped, and what I did was just press this all the way around to kind of put a mark on it, and then I'll pull this off, lay it on the aluminum, and then I'll have a mark that I can cut out and cut the aluminum out of it. Okay, and a little while later I have a piece that fits. It's not perfect all the way around, but I don't need it to be perfect. I can easily fill the gaps while I'm welding, so I'm not too worried about that. But that's what it looks like. So now what I'll do is take this piece back out. It's actually kind of hammered in there. It's in there really tight. It's not going to fall out. So it is tight. And what I'm going to do with this now is start mocking up some runners and make some pulls. And then eventually weld it together. I guess you could say I jumped ahead a little bit here, so I got some of the runners done. I was just in the groove last night and working and didn't really record much. So you saw me drill in the holes for the manifold plate, and then I just cut all these pipes at 4 inches. So what I did was I used the same annealing process that I used to bend these up. So I used a Sharpie on it and then hit them with a torch until the Sharpie mark disappeared. And then I bent these just to help eliminate some cracking, or the potential for cracking. I guess I did a little practice piece with this one and it did crack, so that's why I just went ahead and heated it up. So you're probably thinking that this looks a little goofy because I only got 4 runners, and what am I going to do with the other one? So I decided for simplicity to go straight with the 4, and then I don't have to put any angle on them. And then the plan here is to take this outer runner and then bring it in at a little bit of an angle here. So it's not completely centered on the plate, but it will have enough to come in at an angle like this and then follow the intake. This one will kind of come up something like this, and then the velocity stack will kind of fit in this little gap here. Take this off and kind of show what that looks like. So I did end up shortening these up a little bit. So my plan now is I'll put these on and then weld them in from the backside and smooth it all out. Then I can weld the runners actually in there. I could have just done one long piece and then flared this, but I would have had to find a way to flare that. So my original plan when I made these though, I was going to put them in at an angle. So that's how I did it that way, but this should end up working out okay. So my plan now is to figure out exactly how I need to bring this angle in. So then what this should end up looking like is something like this here. So we'll have pretty close, similar spacing. And then I might bring it in a little bit like that. But we'll have that type of an angle there. And then we'll probably have an angle like this right here, something like that. We'll probably take a little bit of trickery. I might end up notching this out here and then cutting some of the velocity stack out on the other side, where like this could be flat and then butt up against the rear section. But we'll see what I come up with. That was pretty good, huh? Okay, so we got the first mock-up here of the Cast 2 JZ manifold and fabricated onto the 4200. I just have it taped on there, literally. I just got some tape wrapped around it to kind of mock it up. So this just come in at this angle, and I do got some gaps there just because all the pieces are kind of misaligned. But next step is going to be getting this thing out and pretty much getting it to welding. So I am going to clean up all of the pieces. I'm probably going to take like some fine grit sandpaper and sand everything, clean it all up, because it still has like paint marker and everything on it from when I bought it, and everything's pretty dirty, and I want it to be nice and clean when I weld it. But guys, it's actually in there and it really doesn't look that bad. I think it actually turned out better than I thought it was going to look. We'll see what it looks like when I'm done welding it, but either that or I just have so many hours into it that I have to say that it looks good to make myself feel better. Could be one of those. Okay, so I got everything kind of cleaned up. I went over all this stuff with the flap wheel, and then I welded these holes back shut, the holes that I was using to kind of stabilize it with the spacers, and cleaned everything up a little bit with the flap wheel, sandpapered everything. So what I'm going to do now, or I should say next, is start welding everything. I got to weld the velocity stacks to this plate, and then I got to weld these stacks to the end piece here. So I got to do a bunch of welding. But the really special thing is when I turn my gas on, my needle doesn't even move. So there's enough to get a little welding done, but not very much, and I don't want to be in the middle of a weld and then run out of gas. So I'm going to wait on the welding and get this video up. You guys don't really like watching the welding anyways. According to the analytics, there's usually a big dip in the watch time whenever there's any welding stuff. So I'll probably throw that maybe into another video and then work on this tomorrow. And then clean up all this metal because it's really driving me nuts. I got all this metal and dust and flake and crap all over the ground. So I think my total cost into this that I have right now is $238, not including this piece that I had, which I don't remember when I got that. I think I bought that back in the day when I was doing big stereos and I was using big aluminum sections like that for bus bars for large battery banks. So I think I've had that piece for like 10 years and never used it. So we'll do that. Next video we'll be welding this thing up and then mount it, and then after that we'll move on to intercooler. So this intercooler, I'm kind of in the process of like doing a claim and returning this thing because it was damaged in shipping. I filed a FedEx claim, they denied it. I talked to the seller and they said to ship it back, and they're gonna send me another one because it's got that big poke hole in it right there. I have been looking for 8/8 rear ends. There's a couple local that I might go get. Well, not a couple, one. There's a guy that has a bunch of them. Yeah, kind of rolling along here. Hopefully you guys are enjoying the project. I know I am. Building this intake has been really fun so far.